Okay, in this video I'm going to be showing you how to add and subtract mixed numbers, following on from our work multiplying and dividing. I actually think adding and subtracting might be a bit easier because the numbers don't tend to get as massive, which helps when you're doing your conversions. So first thing you'll need to make a note of is that just like when we were multiplying and dividing mixed numbers, we don't actually work with mixed numbers, so we convert them to improper fractions, do our workings out and convert back at the end. Okay, mixed numbers generally are a pain to work with, so we tend to avoid them as much as possible. Okay, and if we do have to work with mixed numbers, change them to improper fractions just to make our life easier. I know it doesn't seem easier, but trust me, it is. I wouldn't even dream of teaching you how to actually work with mixed numbers because there's so many places you can go wrong. As a reminder, before we go on to mixed numbers, I just want you to have a go at adding and subtracting these fractions. You had a bit of practice on this a few days ago. Remember now, the rule for adding and subtracting is that you're only allowed to do it if the denominators are matching, that's the bottom numbers are matching. If they are matching, then great, you just add up or take away the tops and you leave the bottoms alone. If they're not matching, you have to change either one or both of the fractions before you do your adding and subtracting. And that's when they get really tricky, when you've got to start mucking around with both fractions, trying to make them the same. So have a little go at those first, see what you get. Then I'll go through them, because if we can't add and subtract with just normal fractions, we're going to find it really tricky with mixed numbers. Have a go at those. Have a look back in your book if you need to as a reminder, okay, and then press play when you're ready. First one then, the denominators are matching, so that's good, which means we're allowed to add them together. So you add the tops, 3 add 2 is 5, and you leave the bottom alone, it just stays as 8, you don't add the 8, okay. Second one, they're both over 12. So I know the answer is going to be over 12. 7 take away 3 is 4. So 4 over 12, which is actually 1/3 if you divide it, okay, to simplify it. The third one is different because the denominators don't match. So to make them match, I'm going to times this one by 4 because then I'll get 16 on the bottom. So what I end up with is 9 over 16 take away 4 over 16. Remember, you've got to times the top and bottom by 4. Now the denominators match, I can work it out. 9 take away 4 is 5, and the 16 stays as 16. For the fourth one then, so start the second row, get a bit of space here. Again, they don't match. I can make them match if I times this one by 3. Because 3 times 3 is 9. So my new question becomes 5 over 9, add 3 over 9, 5 add 3 is 8, and the 9 just stays as a 9. Remember, you don't do anything with the denominators once they are matching. Now, the fifth one is even trickier again, because they don't look like each other, and I can't make a 3 look like a 4. So what you've got to do here is think of a number that's in the 3 times table and the 4 times table. Okay, the posh name for that is lowest common multiple. The smallest number that's in the 3 times table and 4 times table is 12. So I want to write this one over 12 and this one over 12. Okay, how do you get 12 for the bottom of the first one? 3 times 4, so you've got to times by 4. To get 12 on the bottom of the second one, you've got to times by 3. So on the first fraction, I've got to do 4 times 2 on the top, which is 8. So 8 over 12. On the second one, I've got to do 1 times 3 on the top, which is 3. So instead of adding 2/3 and 1/4, I'm adding 8/12 and 3/12. 8 add 3 is 11, and the 12 stays as a 12. And then for the last one, similar again, look, I can't make a 5 into a 6, so I'm going to have to change them both. The smallest number in the 5 times table and the 6 times table is 30. So they've both got to be over 30. So I times the first fraction by 5, because 6 times 5 is 30, times the second fraction by 6, because 5 times 6 is 30. When I times the tops as well then, 5 times 5 gives me 25 on the top of the first one. 1 times 6 is 6 on the top of the second one. 25 take away 6 is 19, and the 30 stays as a 30. Okay, as long as you're happy with changing your fractions to make your denominators match, it's not too bad. If your denominators don't go into each other, you have to change both. Those are the worst ones. Okay, if you're lucky, you'll only have to change one of them, because it's easy to turn a 4 into a 16, and it was easy to turn a 3 into a 9. It was trickier when you can't turn a 3 into a 4 and you can't turn a 5 into a 6. Okay, so with mixed numbers then, if you did my video yesterday on multiplying and dividing, you'll know the first thing we need to do is change them to improper top-heavy fractions. So 3 times 4 is 12, and the 1 on top makes 13. So 13 over 4, add. 2 times 2 is 4, and 1 makes 5, and that's 5 over 2. Am I allowed to add them if one's got a denominator of 4 and the other's got a denominator of 2? No, they've got to be matching. Can I turn a 2 into a 4? Yes. So if you double it times by 2, our new question is 13 over 4, add 10 over 4, remember to double the top number as well, which is 23 over 4, which is obviously top heavy, it's improper. So now we convert it back to a mixed number by saying how many 4s are in 23. So 4 goes into 23 5 times. 5 times 4 is 20. There's 3 left over. So your final answer would be 5 3/4. It's the same method for all of these. So make them top heavy, get the denominators the same, add them up, convert to a mixed number. So let's do it again. So 3 times 3 is 9, and 1 makes 10. So 10 over 3, add. 4 times 6 is 24, and 5 makes 29. So 29 over 6. They're not matching, but I can turn a 3 into a 6 if I times it by 2. So it's 20 over 6, add 29 over 6, which is 49 over 6. And now you need to know your 6 times table to make it a mixed number. So how many times does 6 go into 49? 6 8s are 48, so it goes in 8 times with 1 left over, so it would be 8 and 1/6. Okay. Next one. If you want to pause the video and have a go at these before I do, that's absolutely fine, or you can watch me do them, whatever you're comfortable with. Okay, it'd be nice if you had a little go at these before I did them, so you could see if you're right or wrong. You'll learn more from that than just watching me do them and copy them. Okay, mixed number to improper. So 7 times 8 is 56, and the 1 on top makes 57. So 57 over 8. Take away this time. 3 times 2 is 6, and 1 makes 7. So 7 over 2. Can I turn a 2 into an 8? Yes, if we multiply by 4. So the new question is 57 over 8, take away 28 over 8. 7 times 4 is 28. That gives us, 29? 57 take away 28 is 29 over 8. How many 8s are in 29? It goes in 3 times. 3 8s are 24. So there's 5 left over, so 3 and 5/8. Okay, they're not easy. I know that, and there's a few steps to go through, but it is the same method every time. Make them improper, get your denominators the same, add or take away, and then convert back at the end. Let's have a look at these ones down here then. Just more of the same thing. These are not getting any harder. 4 times 3 is 12, plus 1 makes 13. So 13 over 3, add. 5 times 4 is 20, plus 3 is 23. Oh, sorry, that's not over, that should be over 4, shouldn't it? Because we're in quarters. Okay, the worst thing about this one now is that we've got to change both fractions because you can't turn a 3 into a 4. So we've got to write both fractions over 12 because the lowest number that's in the 3 times table and the 4 times table is 12. Got to times the first one by 4 because 4 times 3 is 12, and the second one by 3 because 4 times 3 is 12. On the top, 4 times 13 is 52. On the second one, 23 times 3 is 69. Now, adding those together, this isn't great. The numbers have gone massive, haven't they? Because we had to multiply both fractions. That's 121 over 12. Okay, 52 add 69 is 121. Now you've got to know your 12 times table. So how many 12s are there in 121? Well, 12 times 10 is 120. So it goes in 10 times with 1 left over. So your final answer would be 10 and 1/12. Next one's taken away. 6 times 3 is 18, plus 2 is 20. So 20 over 3. 2 times 2 is 4, and 1 makes 5, so 5 over 2. What's the smallest number in the 3 times table and the 2 times table? 6. So we've got to times the first one by 2 to get 6, and we've got to times the second one by 3. So that's 40 on top of the first fraction and 15 on top of the second fraction. 40 take away 15 is 25 over 6. Remember, leave the bottom alone. And then to convert it back, how many 6s are in 25? 4 6s are 24. There's 1 left over, so 4 and 1/6. And then the last example then. So 8 times 5 is 40, plus 4 is 44. So it's already quite a big question, this one. Plus 3 times 3 is 9, plus the 1 on top makes 10. We've got to change both fractions because 3 doesn't go into 5. The smallest number in both times tables is 15. So we've got to times the first one by 3 to get 15 on the bottom, and the second one's going to be times by 5. Get your calculators out if you need to. Okay, I'd rather did that than made a silly mistake. So 3 times 44 is 132. 10 times 5 is 50. When you add them together, you get 182 over 15. And now you need to know your 15 times table. So how many times does 15 go into 180? Okay, if you count it up in 15s, how many times does 15 go into 180? It goes in 12 times. Now 15 times 12 is 180, which means there's 2 left over, so it'd be 2/15. And this is like basically as bad as fractions get. Okay, so if you're finding this difficult, that's why. Nobody likes working with mixed numbers. Adding fractions is hard enough anyway, especially if the denominators don't match. When you're adding them with really big numbers, it's worse. And when you've got to convert it to a mixed number at the end, well, that makes it worse again. So if you're not really enjoying these, you're not on your own. I fully understand this, okay? And the more you work with fractions, the better you'll get. And this is quite difficult considering you've not got a lot of practice with fractions already. So hopefully you've at least followed what I was doing, and hopefully you can be able to do it yourself if the numbers are nice maybe. But the steps are, okay, very similar to what we did yesterday. Convert them into from mixed numbers to top-heavy fractions. Then do your adding or taking away. Make sure your denominators are matching, and then convert back at the end.